Okay, so now we're going to put these skills that we learned in the previous two lectures together and designate a chiral stereoisomer as either R or S. Okay, so first thing we had to do was we identified a stereocenter. That means that that carbon is bound to 4 different groups. So then we went through and we assigned priority to those 4 different groups. Okay. The next step is you have to arrange these 4 groups spatially such that the lowest priority group, number 4, is pointed into the page. So it's exactly backwards here as it's drawn. So I'm going to have to take this molecule and rotate it. This is something that's going to be, you can get quite good at it with some practice. But the first time around, you really want to have your model kit and be doing this. Okay? It makes things a lot easier. I'm going to rotate it a little bit differently than the way that the book does, just because I think my way makes more sense. If this doesn't work for you, you can read what the book says. But what I do when I rotate is I keep one of those bonds the same, right? So in this case, I need this 4 to move over to that position, right? That's the goal. So what I'm going to do is rotate about this bond here. So I'm going to keep 2 in the same position and just rotate those 3 positions. So again, if you had a model kit, it'd be really easy to see that what happens if you take one of those bonds and spin it is you just switch the position of those other 3 groups. So 4 would go to 1, 1 would go down to 3, and 3 would go to 4. Should have used a different color for this, but. Right, so again, this is what happens if I rotate about this bond here, rotating it in this direction. I'm going to effectively swap those groups. Again, 2 is going to stay in the same place, but now I have 4 at my dash, which is the whole point. 3 takes the position of 4, and 1 takes the position of 3, right? So that's how, and the whole point is that I have to be, before I can go about assigning R and S, I have to make sure that that lowest priority group, group 4, is pointed into the board. Okay, so second thing after assigning priorities, rotate your molecule such that the lowest priority group points into the board. Okay, and then what you're going to do is just sort of link your other groups together, groups 1 through 3. So in this case, you're going to draw lines 1 to 2 to 3 back to 1. If you draw a counterclockwise circle, this gets the S designation. If you linked them up in a clockwise circle, that was what would get the R designation. Okay, so this is why we had to assign priorities, and then we go and position our molecule in such a way that the lowest priority group is in the back, and then we figure out whether the other 3 groups are connected counterclockwise, S, or clockwise for R. Okay, so that's the procedure that we do to assign R and S. So let's just do some examples real quick. So first of all, where's my stereocenter? Right there, awesome. It's bound to 4 different groups. Now I got to go in and label the priorities of these groups. So highest atomic number would be iodine, then bromine, then chlorine. My carbon is 4. So this is kind of best case scenario where priority group, group priority 4 is already pointed into the page. So I don't have to worry about doing any rotations. Now I can just link these up. 1 to 2, 2 to 3, 3 back to 1. This would be the S stereoisomer, right? Because it's going counterclockwise. What about this one here? So again, I have the same groups, so I can sort of fill in my numbering pretty easily. This is 4. Again, best case scenario, that 4th priority group is already pointing into the board. So then I'm going to link these up 1 to 2, 2 to 3, 3 back to 1, and that is the clockwise direction, right? So that would be the R stereoisomer. All right, let's look at a few harder ones here. These, I say they're harder because, unfortunately, the lowest priority group is not where it needs to be, right? So first step is still the same. We're going to go in and assign priorities. Just based on atomic number, we can see that bromine 1, chlorine 2, carbon's 3, and hydrogen's 4. The hydrogen's not in the right position. So I'm gonna have to rotate this molecule in order to get it there. You can sort of pick a few bonds. I'm gonna pick this chlorine one here, and we're gonna rotate everything about this bond going this way. So in terms of my positions that are gonna be swapped, right, I'm not assigning R and S here, I'm just rotating this molecule. That means that the hydrogen's gonna go where that methyl group is, that methyl group will go where the bromine is, and the bromine will go where the hydrogen is, if I rotate about that bond. And of course I'm gonna do that because I want that hydrogen in that back position. Okay, so now, chlorine didn't move, it stays, but the bromine took hydrogen's position. Hydrogen is now where that methyl group was, and that methyl group is now sticking out at me. Okay, so then we go back, fill in our priorities again, 1, 2, 3, and we see that this is a counterclockwise connection, right? 1 to 2, 2 to 3, 3 back to 1 is counterclockwise, so this is S. All right, another example where hydrogen isn't where it's supposed to be. I can first go in and assign groups to convince myself of that. Chlorine gets 1, hydrogen gets 4, lowest atomic number. These are both carbons, so which one's gonna win? Now I gotta look at what they're bound to. So this gets 2 and this gets 3. So now I have to put that hydrogen in that position. So this is a good idea. It's a good idea to take a second, pause the video and see if you can't draw that before I do it. Okay. What I'll say is your drawing, is it? Okay, so I'm gonna rotate about this bond here going this direction, meaning that my hydrogen is going to swap places with the methyl group. That's my whole point. The methyl group swaps places with the chlorine, and the chlorine swaps places with the hydrogen. Okay, so again, the chlorine took hydrogen's place. Hydrogen is now in the back, and that methyl group is now sticking out. And again, just putting in priorities, 1, 2, 3, and then I'm gonna link them up. 1 to 2, 2 to 3, 3 back to 1. That goes in a clockwise direction, so this is my R stereoisomer. Okay? And this is actually how you would go about naming these molecules if you're specifically talking about a particular molecule. So for example, this alcohol here, we see that it has a chiral center, and thus there are stereoisomers. What are pictured here are a pair of what? What do we call them? Enantiomers. Okay, so I wanted to refer to a specific stereoisomer. I would refer to it as the 2R2-butanol. Here they just said R. I'm going to, because this is how I learned it, always say like 2R. They tend to, your book leaves it off if there's only one. If you want to do it that way, that's fine. But the super correct way, or the way that you can't go wrong, is to also include the number and the name. So 2S, the 2 being the position of where that chiral center is. So this would be 2R2-butanol and 2S2-butanol, the pair of enantiomers. We haven't gone over naming alcohols yet, so don't worry about it. We will formally go over it, but I do just want to point out these have a different suffix, right? So we don't name alcohols with prefixes, we name them by changing the suffix, and the position of that alcohol group is still indicated by a number. Okay, now in this molecule here, we actually have 2 different stereocenters. There's one right here, and there's one right here. So if we're going to be talking about a unique stereoisomer, we're going to have to include both of those designations. So this would be 2R, 3S, 3-methyl. That lets you know that this stereocenter has S chirality, and that the 2, which refers to the alcohol group, has R stereochemistry. Okay? So yeah, so that's how we would go about putting these designations into the name, into the IUPAC name for molecules. The last thing I want to go over is everything's, we did these previous examples where it's drawn as a tetrahedral. That's all well and good, but really when we look at bond line structures, we don't really look at them as tetrahedrals. We look at them as something like this with wedges and dashes. So let's learn how to go about assigning R and S easily on a wedge and dash kind of bond line structure here. Okay, so this is kind of best case scenario. And why is it best case scenario? Because the implied hydrogen is already pointing into the board, right? So all I have to do is go in there and assign designations. So this is priority 1, this is priority 2, this is priority 3, hydrogen's obviously 4. And that means that these link up 1 to 2, 2 to 3, 3 to 4 in a clockwise fashion. So this is the R stereoisomer. All right, so that's kind of best case scenario when your hydrogen on your chiral carbon is already pointed into the board. And again, we said, let me just make it a little bit neater. This is the R stereoisomer. So if we wanted to be really good, actually, we can go ahead and just name the whole thing. This would be 2R, 2-chlorobutane. So now I'm going to erase this just so we can compare these two molecules easily. Hopefully you can see, but based on what we did before, that this is a pair of enantiomers, right? All I did was flip my wedge and my dash. So I already know, I don't even have to do any work because I already did it over here. I already know that this is an S, okay? But let's go about how we would figure that out if we just stumbled on it. So first of all, I want to show, I'm going to label priorities. This is still 1, this is still 2, this is still 3. As it's drawn, they connect in a clockwise, but it's S. So in this one, my implied hydrogen, whoops. My implied hydrogen is sticking out of the board. Now you could take this and you could rotate this molecule just like we did before. That's perfectly fine, but I'll save you a step. If your hydrogen is actually pointed out at you, then you can just reverse the rules. So instead of clockwise being R, clockwise will be S. And we've kind of proven that here. We know that this is the S designation. Our hydrogen's pointing out at us. So now clockwise would be S and counterclockwise would be R. So when you encounter this sort of situation with a dash bond, meaning that the hydrogen is sticking out at you, the implied hydrogen is sticking out at you, just reverse the rules for R and S. Okay, so let's do a little bit more complicated of an example here. This is a good idea to try on pause and try on your own. What's my first step got to be? I got to identify the stereocenters. So I have one here. This is one here. And I also have one here. Okay, so let's look at this first one. Got to go through and assign priority. Again, kind of best case scenario because my hydrogen is pointed into the page already, so I don't have to worry about doing any rotating. But just to assign priority, this one, they're all carbons, right? So then we got to look at what else they're bound to. This carbon is bound to 2 other carbons, so it will get priority 1. This carbon is bound to just 1 other carbon, so it's 2. And this one isn't bound to any carbons, it's bound to all hydrogens, so that's priority 3. And so for this particular stereocenter, we got, just to keep my colors consistent, we got 1 to 2, 2 to 3, 3 back to 1 in a clockwise fashion. So that makes this an R stereocenter. All right, I'm going to get rid of my priority labels just because it might get a little bit confusing. But we'll just note that that guy's R. Now I'm going to jump to this stereocenter here, and I got to label all the groups around it with their priority numbers. Okay, so here we again have all carbons, carbon, carbon, carbon. carbon, they're all carbons, so they're tied, so we got to go through and figure out what's next. This carbon is bound to 1 carbon and 2 other hydrogens. This carbon is bound to 2 carbons and a hydrogen, and this carbon is bound to 2 carbons and a hydrogen. Okay, so notice right off the bat, this guy loses. I guess I should have drawn in the fact that we have this implied hydrogen here, which is going to get priority 4. But now this guy, it's lost, so it gets priority 3. Now I can move on to the other ones and figure out where they rank, because they both have carbon-carbon-hydrogen bonding patterns. Notice that now our bond, now we got to keep track in sort of multiple directions here, because I'm going to have to jump to the next carbons. So here and here for this side. Where this carbon's bound to 3 hydrogens. This carbon, hydrogen, hydrogen. Same thing over here. These are all 3 hydrogens, all 3 hydrogens. So the fact that there's a carbon on this one is what has it winning. So it will get priority 1, leaving this, whoops, 1, leaving this guy as 2. Okay. Make it less busy here so we can see what's going on. All right, so I've assigned the priority of all the groups that are about that stereocenter and the specific stereocenter that I'm focusing on now, which is this middle one, this guy. Okay, so then I'm going to connect everything. 1 goes to 2, 2 goes to 3, 3 goes to 4, I'm sorry, 3 goes back to 1. These are counterclockwise, and my lowest priority group is pointed into the board. So that means that this would be S. So now let's look at the last group here. Whoops, don't want to get rid of that. Said this was R. So now I'm going to look at my last chiral center here, this carbon. On this one, assigning priorities isn't so bad. What's unfortunate is the fact that that hydrogen is not where it needs to be. It's pointed out at me instead of being pointed into the board. Assigning priorities isn't so bad. This one's 1, this one's 2, this one's 3, hydrogen's 4. But again, the easiest thing that you can do is to just flip the rules for how to assign R and S. If you have a wedge like this, meaning the hydrogen's pointing at you, then now clockwise means S and counterclockwise means R. So this goes in this clockwise fashion, but the hydrogen's pointing in the opposite direction, so that means that clockwise means S. Okay? So now it's a good idea to take a second and actually name this, give this compound its full name. I'm going to have to start numbering from this side because that fluorine has to have, would be group 2, whereas if we numbered from this side, it would be 3 for the methyl group. Okay. Now you're going to put all your stereoisomer information at the beginning in parentheses. So this would be 2S, 4S, 5R. And then we're going to list our groups in alphabetical order. This would be 2 fluoro, 4 isopropyl, 5 methyl, heptane. So you can see things can get pretty ugly pretty quickly in terms of these namings. But yes, this is sort of these skills that we've learned up until this point. Again, these are just sort of the tricks for when you're using bonds, for when you're assigning R and S to bond line structures, which is going to be the most common situation.